Hello and welcome to Upstream Intelligence's webinar, Doubling Down on Digital to Optimize Operations, brought to you by Reuters Events. My name is Jade Waters. I work as an analyst at Reuters Events, as well as being this year's project director for the Data-Driven Drilling and Production Conference taking place in Houston this June, which we have produced in conjunction with this webinar. This webinar is just one of several pieces of work we're doing to promote the industry and the key issues within it. There are over 200 of you signed up today, so thanks very much for the great response, and thank you in advance to our panelists for their time. Just a brief bit of housekeeping before we begin. This webinar will last 50 minutes to an hour and is being recorded, so we will send you a full audio recordings and presentations within a week or so. You do have the facility to ask questions, which our chair and I will navigate and process at the end of the webinar. The purpose of today's session is to take a closer look at the digital solutions within operations. How do you digitally enable projects that are remotely controlled and minimally manned? How can you digitally enable the major project process? And finally, how can digital be used to hand over from projects to operations? Joining me as speakers today to address some of the key issues are Dave Hartell, who is Executive Vice President of Operations and Production at New Age Limited, and Naser Tamimi, who is a data scientist at Shell, as well as being the co-founder of NewDAX, who provide AI solutions to upstream O&G companies to help efficiently develop their oil and gas resources. All of the topics discussed today will be elaborated on in Houston this June. So if you want to learn more, then be sure to join us there by registering at www.upstreamintel.com/data. Do remember, if at any point you want to ask the panelists a question, simply enter this into the text box and we will try to address it in the Q&A at the end. So without further ado, it's time to bring on Tony Edwards. Tony is CEO of the digital oil field and integrated operations consultancy company, Stepchange Global, and will be our chair for the session. Tony, over to you.
Thank you very much, Jade. It's a pleasure to be chairing this panel today. Just a little bit of an overview. What we're going to try and do today is give you an overview of the digitalization of the major project process. There's clearly lots of focus on digitalization of brownfield operations for very, very good reason, but we think there is an underrepresentation in the application of digital to the major project process from concept, selection and development all the way through to handover to operations. So that's what we're going to try and focus on today. We're also going to look at this in a couple of streams. So we're going to say, one, what's the kind of operations facilities stream and setting up that context, the concept all the way through to the operational model. And then Naser is going to look at the flow of the subsurface data through from exploration and discovery all the way through to handover in the operational phase. So that's what we're going to try and achieve today. But first of all, I would like each of our panelists to give themselves a little introduction and their background, particularly with respect to digitalization of the major project process and their experience. So David, if you'd like to go ahead with that first.
Sure. Thank you very much, Tony and Jade. I have extensive onshore and offshore development experience all over the world, especially including some remote locations in the South Atlantic, West Africa, in Northwest Shelf, Australia. And in all these locations, I've been working with integrated intelligent operations and production for the past 10 years. And as Tony reminds us, this is a process that needs to start very early in concept select to have a good successful outcome by the time we hand over to operations. Naser?
Thanks, Dave. Again, hello everybody. This is Naser Tamimi. As Jade mentioned, I'm one of the NewDAX co-founders and a data scientist in Shell. My background is in geophysics, and for the last few years, basically, I focused more on the subsurface digitalization and AI applications and how we can take advantage of these available technology, artificial intelligence, machine learning, and many other exciting technologies to better characterize our reservoirs and our basin. So that's what I'm also going to focus on today, mostly on subsurface digitalization, and I hope that together with this panel we get to a good point and good understanding of where we are in terms of the digitalization and where we can go after that. Thanks.
Thank you very much, Naser. And just to complete the three of us, my name's Tony Edwards. As Jade already said, I'm the CEO of Stepchange Global. We're an independent digital consultancy and advisory company, but my background and my passion is in operations. It's where I grew up in the North Sea. It's where I was involved in operations management, both offshore. And as part of that, I was the operations engineer, offshore operations engineer and OIM for a bunch of unmanned platforms in the southern North Sea. And one of the things that I've been trying to do is bring, that part of my early career together with the digital experience that I've gained since 2003 in BPBG and in Stepchange, and bring that together to really push forward on what we understand of new operational concepts and how we can go to what I would call radically minimum manned project concepts from day one, and how we can use all this data and information to really push the boundaries on how we operate our project concepts in the future. So without further ado, we're going to jump into the slides. Jump forward to one. First of all, what I'd like to say is that you cannot start early enough with this idea of applying digital and applying new project concepts. It really starts out at your project kickoff. And the thing you need to be concentrating on is how are you going to operate these new project concepts. And what we see here is a bunch of typical offshore concepts that we see. And typically, many of these concepts, especially the large oil-based platforms, FPSOs, semi-subs, would have significant crews and would all be locally run and locally operated. What we see now is that it's entirely possible, with the application of digital and other technology approaches, to have many of these concepts remotely controlled, and also have them much simpler facilities, and because of that, much lower in manning. So what we're beginning to see now is the evolution and development of very early phase projects, which are either completely unmanned or very low manning. And the current state of the art, I would say, is for gas platforms and gas operations offshore, they can more or less all be unmanned. We have seen the development recently of concepts which include having acid gas removal and significant compression capacity and high volumes of gas production with associated liquids. And we are seeing concept designs on the drawing board which are already unmanned for those types of operations. When it comes to more complex oil operations, we are also beginning to see that, a traditional, say, 100,000 barrel a day FPSO, which might have had a persons on board of 60, 70 or 80 people, now we can see those being developed with sub 20 POBs. But this requires a number of things. One, you need to understand how you're going to operate this platform and what your operating model is from day one, and you need to design it that way. You need to have excellent alignment between your operations teams who are going to run it and your projects teams that are going to deliver this new concepts. And also you need to have a challenge process within your organization and your project to challenge the norms around what we currently see is the normal way of developing and running these kind of operations. But the size of the prize is significant. We are seeing OPEX reductions, potential OPEX reductions of between 50 and 80% for these new types of concepts, and we are seeing CAPEX reductions in the range of 5 to 40%. And typically, you see those reductions are higher in offshore platforms than in onshore, but those are the kind of metrics that we're seeing. We know, as you can see on the graphic here, there's a small, wellhead tower. We know of wellhead towers and have been involved in development of these where they are going to have yearly visit frequencies now. So, you know, gone are the days where you have to visit these things every 2 weeks or even every month or even every quarter if you design them right from stage one. We also see this happening in land-based operations, but the metric that we see in terms of manning is different, and we describe this in terms of a visit frequency. So are your sites or your well pads or your facilities visited daily, every 2 or 3 days, weekly, bi-weekly, monthly, quarterly, and where can you get that get to with this kind of approach? And certainly we're beginning to see well pads where you just don't need to visit them on a very frequent basis at all, and by using the latest automation and latest technology out there to for predictive maintenance, you can move to a full operate and manage by exception model and only really visit the sites when you need to visit them. So this is the exciting world that we're getting into. We're seeing this as a series of like what we've termed radically minimum manned operational concepts, and you know, we are seeing these coming through the project processes at the moment, and we are expecting a whole bunch of them to be coming online over the next few years. And as I said, the size of the prize is significant in this. So that just gives you a picture of the context that we're in. So how do you get from, you know, this idea of a radically unmanned minimum manned project concept through to delivery and full operation? That's what we're going to talk about next and ongoing. But first of all, I think we're going to hand over to Naser, who's going to describe the interface between subsurface engineering for us and go through that whole subsurface data and information flow through the project process. So over to you, Naser.
Thanks, Tony. So Tony did actually an overview of surface digitalization and surface facilities. That was very good. Let me invite you to thousands of feet below the surface, where we have the subsurface, and I'm going to focus on the subsurface digitalization. Basically, the idea of subsurface digitalization is how can we integrate G&G, which is basically geology and geophysics, with engineering, which are mainly drilling engineering and reservoir engineering, all together with the artificial intelligence and data analytics. So that's the idea behind the subsurface digitalization. And the benefit of that would be always and always in the subsurface, what we want to reduce is the uncertainty. The subsurface is the, in the operation and in the oil and gas is where we don't have the direct access to that. And there is a big uncertainty associated to that part. So this integration and digital subsurface digitalization aims to have this uncertainty reduced. Just before going to let me go to the next slide. And so yeah, just going before going further, I would say that maybe it's a better idea to have the digitalization, in common ground in digitalization. So the digitalization is basically can be done at 2 stages. And so this is really good to, understand that what are the differences between those 2 stages. The first level of digitalization is the data level. At this level, basically, what we are trying to do is we are switching from the analog data to digital data, and we are trying to acquire digital data. I should say that this part of digitalization is not new to the oil and gas industry. Basically, for a long time, we are acquiring digital data. But honestly, this type of digitalization by itself might bring low value or no value, at least in the subsurface. What do I mean by low value or no value? For example, it's like an extreme example. If we acquire digital log and save it and store it on our computer, but every time that we want to interpret that, we will print it on a piece of paper and start interpreting that. Yes, we are using the digital data at the data level, but basically we are not bringing any digitalization value to the table or to our process, basically. So that's why I mean that the data level digitalization by itself has low value, and it also been in the oil and gas industry for a long time. However, recently maybe some new aspects and new technologies has happened that makes even this part of digitalization interesting. Technologies like IoT and subsurface sensors and those things are new technologies at this part. But what I want to focus on and what I believe is the more important digitalization is the process-oriented digitalization. When we bring the digitalization to the process, not only the underlying data. Of course, this has a very high value, in terms of the saving time, in terms of the saving cost, in terms of the accuracy. And honestly, for the last 5, at most 10 years, we are working on this kind of digitalization in the oil and gas industry. In the heart of this process-oriented digitalization, we have technologies like artificial intelligence and machine learning. So every time that you hear those technologies, basically we are talking about the process-oriented digitalization. So, but let's go to our specific topic, which is the subsurface part of this technology. To be more organized, and because this topic is a very large topic, I try to categorize it at 4 phases of the oil and gas, life cycle. So the first phase that I will, talk about would be exploration, then characterization. The third one is planning, and eventually we go and talk about operation. At each of those phases, I try to give one example of digitalization and how it's changing the process. Probably you can grasp the idea and have more examples of how other digitalization applications are being applied to any of those parts. Let's start with exploration. At the beginning, I should tell you that every day, at least in the oil and gas industry, we are hearing, hype words like big data. I should say that probably, at least in the subsurface, the data that we have in no measure is the big data. Actually, in the subsurface, we are facing with exactly the opposite problem, and that's the problem of small data. Especially this happens at the exploration, which is the earliest stage of exploring a basin or a field. We don't have too much of information, and we cannot even talk about the big data. We should focus on the small data. How can we get the knowledge from every possible source of information? How can we connect those knowledge? For example, let's say I'm going to a new basin. I know Permian Basin is not a new basin, but let's say that we are at the earliest stages of Permian Basin and we go to that basin. We don't have any information about its geology, about its engineering. So we need to grasp this information from other documents, from other source of information. And from those other documents, we can be connected to other documents. And every document and every source of information can provide us a little bit knowledge, and those should be integrated. For example, one of the applications of the subsurface digitalization at this time is how can we make the knowledge graph out of many, many documents together, connected and talking to each other. This is the idea that is possible through the natural language processing, which is a very advanced AI topic. So as you see now, for example, in exploration, we have a problem of small data, and we are addressing that problem with the NLP and with artificial intelligence and digitalization. So this is one example that I should say that we can take advantage of this era. After exploration, as I mentioned, we start characterizing our basin or our reservoir, basically. So unlike the exploration phase, in the characterization phase, basically we start acquiring more and more data. Still, we are not in the big data area. I should emphasize that. But anyway, we are getting too much of data in a short amount of time. Data such as the new well logs, the seismic data, and many other kind of the subsurface data comes in a short amount of time to build a reservoir model, to build a basin model. That's where most of the geologists and geophysicists start processing and interpreting the data. And I should say that the characterization probably is the longest process in the subsurface. It might take years. But we know that we should make this process much, much faster. This is again where the subsurface digitalization and AI technologies are right now being playing an important role. For example, with the machine learning techniques, right now we are doing this log interpretation much, much faster. And then we can put the human experts just at the QC of the results to make sure that everything the computer is doing automatically is right. Or on the seismic, most of the processing and even most of the interpretation, for example, picking the seismic horizon, which takes too much of time from the geophysicists, right now have been started to be done by the computers. Technologies such as deep learning and reinforcement learning, which are the pioneer technologies in the subsurface digitalization, are right now being used to make this process of characterization faster and bring the reservoir model for the next step more accurately and of course more faster than before. So the next step probably, as I mentioned, for most of the fields and basins is the planning. If at the characterization, we had many of geophysicists and geologists involved in this phase, I mean planning, we have engineers, mostly reservoir engineers and the drilling engineers involved. One of the things that we should keep in our mind is usually because we are limited as a human, we are limited in the number of the comparison and in the number of analysis that we can do in our mind. So because of that, when it comes to the planning, when it comes to the designing, for example, a pad or something like that, we go with the limited number of scenarios. And because we are going with the limited number of scenarios, we are in the area of suboptimal solution or suboptimal production, for example. We cannot get to the optimal solution or optimal production unless we expand our analysis to all possibilities in terms of the planning and add the uncertainty to the problem. So human by itself cannot make decisions that says, okay, among millions of possibilities and among millions of uncertainty that we have, what is the optimal solution? That's where artificial intelligence, which is based on the subsurface digitalization, can bring us some value and help us to make decisions. That's where the AI decision support systems are emerging, and they are helping us to make the better solution, which probably lead to the optimal solution instead of suboptimal solution. And I should tell you that, again, the final decision making is on the human side, but AI and digitalization is serving as our advisor and telling us that instead of focusing on all of the million cases, it screens out the best planning designs and the planning strategy and tells us that you might need to focus on those things. Again, it's not possible without having the digital data and digital process. And probably the final phase of subsurface digitalization is when the field is operating and we are in operation stage. At this stage, wells are producing and the facilities that Tony and Dave are covering are producing and capturing the oil and gas that we are producing. But the problem is we can do a better subsurface understanding and characterization even at this stage. with the feedback that we get from the surface facilities, we can update our understanding from the subsurface, and eventually this might come as a value, as a better value, as a better production. For example, if I want to give you an example in this area, we have the concept of autonomous wells. The autonomous wells are the wells that, we have the surface facilities with too many of, sensors, and those sensors and their responses over time updates our subsurface model, and because of this updating we can make the better production, and this has been done with no human intervention automatically. So for example, the well sees that there is some problem that might need to reduce the pressure or increase the pressure, and then we can get the much more oil from the subsurface. So this is what we have in terms of the subsurface, digitalization, from the beginning of exploration to even the operation. We can use all those available technologies to increase our understanding from the subsurface and use it in our own advantage.
Okay, thank you very much, Naser. From subsurface, we can now just backtrack a tiny bit there. After the results of some of the exploration and appraisal wells at the start of the project designing the facilities, there's things that we can do to digitally enable our project processes. This is how we're going to be doing various analyses, various design work, getting various data of our facilities. How do we capture all this information in a systematic, reliable way that it will be able to help us on the path through to successful operations? So one of the first things that we need to do is some kind of a 3D CAD model, or in the case of existing facilities that we might be modifying or doing brownfield on, some kind of laser scan point cloud models. These kind of tools, these models are very useful, obviously, for design purposes, but they're also going to be used, as we see in the next couple of slides, to hang a lot of contextual data off of. So very important. The technology is really improved. It's gotten very easy to model these things, and these are going to give us a good reference point as we start adding data. The information that Naser mentioned about the subsurface, the G&G data that's collected, the work that the reservoir engineers do, the models they give, it's very important to try to tie these together with the rest of the facilities. Historically, sometimes subsurface teams have worked a little bit in isolation, separate from people that are maybe doing, in the case of an offshore development, the people that are doing the subsea architecture, or separate from the people that are doing the surface facilities. And really, they need to be interconnected to properly optimize the output of our wells and get the most out of our reservoirs. Dynamic simulation models that go from the reservoir through the wells to the surface, to the wells, and on up to the surface production and process facilities. These are models that we use in the design phase to size all of our systems, to size our equipment. Also, we start putting control system emulation in there to design our control systems, safety and control systems. Very powerful tools that start very early on. And again, looking forward to the eventual handover to operations, the work breakdown structures, the tagging, how we identify all of our equipment, all of our systems and everything. We need to develop these kind of systems very early and build on them. They'll be used in our document control with metadata. They'll be used in our procurement activities, our suppliers. When we start building things in construction phase, we'll be getting equipment data linked into these tags. We'll be getting the information from the vendor testing. We'll be using this in our instrument control and safety shutdown control systems, and then eventually our screens with the HMI interfaces for the operational room. All these tags, all this metadata, all the object data, very, very important to build on and start early and have that to be to encompass our whole system from the wells downhole to the wellheads up to the surface facilities. So over the course of the design work, we'll be producing various packages of information by the projects to be handed over. I mentioned the 3D CAD model. Now is the time then when we have contextually identified information. So you'd be able to go into the 3D CAD model, select a piece of equipment, a piece of piping, or whatever. You'd see the tag number, you'd see all the information there. So an underlying contextual database would have our design criteria, our standards, our specifications, whatever calculations we've done to come up with and size those things to determine our operating windows, all the basically structured and unstructured data. So technical reports, material and equipment, systems, data sheets, specs, all this information will be underlying and linked in through these databases. This is a really powerful tool that, the days of having large technical libraries full of hundreds of paper books that nobody can ever easily find stuff is being sped up by these kind of digital systems where we can quickly access all the information we need. And the engineering analyses that have used these dynamic simulation models will be advanced over the course of projects into our digital twins. A digital twin is the simulation of from the subsurface through the wells to the surface facilities, and will be a tool for us then, as you'll see in the coming slides, to then check how our facility is doing, how our operating envelopes are working, whether we're seeing any degradation in our performance, and we'll build on all this. So this is key building blocks that the project teams be putting together and have these as tools that will be eventually accessed by the operations teams. So again, the underlying information from all of our suppliers, tremendous amount of thing. We have, hundreds and hundreds, thousands of tagged items, all the database with all this equipment, all the documentation, all the drawings, videos of how things are tested, how they're assembled, how spare parts go in, instructional videos of how to diagnose things, how to troubleshoot, the manuals for how to perform operations and maintenance, what kind of spares we need and how they go. These are some pictures that basically show some of the tools we have using things like virtual reality or augmented reality. We're going to be populating these databases, this information over the course of the project. So the design information will go in as we tender and quote and award to vendors and suppliers. Their information will start coming in, building the database. During the fabrication and construction in the shipyards or in the construction yards or in the onshore sites, lots of information, as-built information, dimensional data, certification, inspection records. All this is building to provide the tools that the operations team are going to need to run safer facilities and have more successful maintenance. And these pre-commissioning, commissioning procedures and testing records, it's really important to build on that. Part of a flawless delivery of a project is to get all this right. We don't want to get into operations phase and not really be able to ramp up or have problems in the early days. So all the pre-commissioning and commissioning that we can do, building confidence in our systems, that things are going to be operated as and performing as we've designed them to be, to ensure that we have the integrity, that we've pressure tested things, we've electric tested things, have all these records. And some of this information will be then used to check the performance of this equipment down the road. So if you have valves that have certain signatures of how long they take to close or open, what kind of pressures to do the actuators, what kind of delta P across valves and chokes. We want to save all that because all that's going to be used eventually in our analytics process during operations. So finally, we get to the point towards the end of the project. The operations team have been showing up and joining. These are very valuable part of a digital transformation process to lead to operations. The operations people have to get in there early. They're doing their pre-operations planning. They're actually going to take the dynamic simulation digital twins that we've put in the control system emulation. They'll be using these as operational training systems to train the operating crews. What's nice about this is instead of waiting until you get into the field during startup and debug a control system, you're actually going to get some very experienced people running through these training simulators. And if the theoretical design of the system, the control system, if it has any kind of bugs or inefficiencies in it, actually you often catch these during the training of the operators, and you're able to fix these things before your facilities leave the shipyard or the fabrication yard or before they're completed. So it's a powerful tool. And these kind of simulators are really important to have a instrument control safety shutdown system and all the logic. You don't design these systems just for some sort of hypothetical easy startup and then run at your nameplate capacity. There's a lot of operating scenarios that we need to test our teams on, all sorts of various conditions during the ramp up, during various production cases, different amounts of liquids or gas or water or various upset conditions. Good opportunity to train our crews, but also all of these things are testing our theoretical design of the safety and control systems to make sure they're going to be robust for the real world. So the logic has been tested, our operators have been tested, and again, during the first year of production, then we're going to get up to plateau quicker and stay on plateau longer. It's going to have an ability to capture a significant amount of value in that first year of production, which historically has been lost. Just trying to go to the next slide. So operations have witnessed and participated and are part of the acceptance process of all the completion and testing work. This is basically the operations team taking ownership. You're going to have very qualified operators that know the facilities very well, that have confidence in how the equipment is going to perform, how the control systems are going to be. All this is going to help us with our manning. As Tony pointed out earlier, the more that we've had a flawless delivery of our facilities, the more things have been tested, the more our people have been trained. It lets us have smaller field teams that are essentially only going to be supported remotely by remote technical experts. So this is all part of getting a more efficient manning of our facilities, even unmanning, and will save us significant amounts of OpEx. Maintenance, again, is another thing which had to start early. In fact, really at the start of design process, you should be planning for how you're going to do your maintenance, how you're going to have an asset integrity management plan, procedures, all your detailed instructions. It isn't just the training of your operations teams, it's the training of your maintenance teams. That significant amount of maintenance work is often inefficiently done because people aren't really trained, they're not really ready, they don't have all the equipment, they haven't done the necessary amounts of isolation from pressure or hydrocarbons or energy. And so having all this worked over the course of the project to prepare for this is going to prepare your maintenance teams to get out and do things right the first time and have the tools they need to keep training themselves, to keep preparing for things, to help do diagnostics. And back to what Naser talked to us about, the subsurface results. During operations, you're never going to have, you're never going to exactly operate a field the way you've theoretically analyzed it. So you want to make sure that you have the results of your subsurface data, you have all your models ready, you're monitoring your wells and your control systems, all your downhole IoT devices, your wellhead IoT devices. We want these things tested, set up, ready to go. We want to be able to compare the model results, the numerical outputs of our dynamic simulations with the actual well results to adjust our physics-based models. Naser showed that on his last slide, and so this will happen. For the reservoirs can be quite complex, and so to exactly model these with a theoretical physics-based model could be difficult without being able to take this data and tweak it slightly, especially at the beginning of life. And more recently, people have been using machine learning and AI tools to derive something called data-driven models, which is a way to try to predict and evaluate the performance of our wells, not just using physics-based type models. This is going to be a tremendous, powerful tool. If the operations teams would have been there the whole time, the maintenance guys have come in, gotten prepared for project handover to operations. Guys are ready to go. They've got the information. They have the confidence the system is going to behave as it is, and we'll be ready to run these things, whether they're unmanned facilities just being monitored by remote operations teams, whether periodically maintenance teams will show up at the facility to do their maintenance, get it right the first time, and then go back to their base. All these are things which the digital transformation efforts will give us powerful tools to optimize our operations. Tony?
Yeah, thanks very much, Dave. I mean, just to sum up, the size of the prize here for moving to this digitally enabled operating model from concept generation and selection all the way through the project process and handover to ops is considerable. I mean, it absolutely is a game changer. We are seeing the potential for improved recoverability as Naser talked about in his subsurface section. We're talking about improved reliability across wells and all of our equipments, and we're already seeing this emerging. There are a few operations which have been ahead of the game in terms of digitalizing and unmanning their facilities, and they're getting extraordinarily high uptimes, 99%, and even facilities are getting are around which are not getting a trip in a year, or an unplanned shutdown in a year. So this, this has a significant impact on your production and your recoverability. Also, in terms of operability and maintainability, we're seeing that platforms and operations which typically would have had tens of thousands, if not 50,000 hours of workload or maintenance, can now be simplified and remotely monitored to such an extent that that gets as low as 10,000 man hours a year, in which case you have the ability to unman or very low man these remote operations. So the size of the prize is really high. But just to the last 2 points, this is not just about the technology. This is about fundamentally changing the way we work. It's about changing the operating model. It's about changing the organizational model. It's about changing the traditional processes and how they've been run through the whole entire project process, and changing the way we manage uncertainty in the reservoir and in the well. So this is a fundamental change in the way we work. It's not just about the technology. It's about changing your processes and procedures. It's about bringing the people on a journey. It's about aligning your organizational and operating models to take benefit from this. And so it's actually much more than the technology or the sum of the technologies. The other thing I think is significant is that if you walk into an office where one of these projects is being managed in a digitally enabled way, it does feel very different. The culture is different. There's often an argue to add in equipment instead of an argue to take out equipment. It's very much a challenge process. You find that a lot of the silos which are traditionally there between subsurface and surface, or projects and ops, are gone, and that is very empowering for the people involved in the projects. It's very exciting. It's very much the description of the new way of working, and you can get some remarkable outcomes if it's done well. But you've got to have that challenge mentality, and very much that kind of one team approach. So with that, we're very we're very happy to take some questions. So please, could we, if we have any questions, and in the meantime, I would throw one of the questions back to Naser and to Dave and say very much, what's your experience of this change in the culture that you've seen going on within the companies you've had experience with, and is that a key part of the success that we see happening? Dave?
Yeah, it's actually a little bit depressing, the numbers. There's a statistic that 78% of pilot programs fail. And it's often because people have gotten these tools, but they haven't changed their people and process, the culture. The days of everybody in a silo, multiple single disciplines being detached, that just doesn't work so good. So people are trying to have smaller, more agile teams closer to the asset, multidiscipline kind of teams. Those are the ones that have more success. And one of the companies that actually was successful doing this, they spent 50% of their budget on changing their workflows. And so this isn't just about the technology. The technology is certainly important, but how you change the organization of your teams and your workflows is as important. And we got to do something to improve the statistics.
So from my experience, that's interesting that digitalization at this time are being used and advertised by, I would say, two front of people in the companies. From the top, the managers and the head of organizations can feel the necessity of moving toward this digital era and making the digitalization as the everyday process. Also, I can see that the people at the technical level, the people who are doing the job, feels that today they need to change from the traditional way of doing to the more digitalization and more smart way of doing things. The problem, not the problem, actually the challenge is at the middle, where we have the those who are responsible to do the project, those who are responsible to deliver the project, and they are being forced from the top to use the digitalization, from the bottom to want to invent something, but they are not sure if this digitalization can help them to deliver the projects on time. And I can see that this is the group that would be determining in every company to push the company toward this new era of digitalization, or prevent them from going that far. I'm feeling that if those people are seeing the benefit of this, for example, the benefit of digitalization in facilitating the process and making the project delivery faster, or bringing some values that was not possible before, those also will help this process to go through. The other things that in terms of the the value, I see now that the companies, for example, in unconventional resources, they are looking for a little bit more of recoverability, and when they see that just with the digitalization and those kind of data analytics, they can increase their production by 15%, they get so excited, and they don't even know that this is possible through just by changing their process. So I'm feeling that, we are going that way, but we should show the values to people who are delivering the projects and showing that this digitalization has something with them.
Thank you very much, Naser. I mean, one thing that always occurs to me when we're going through these digital projects is we often learn more from our mistakes than we do from what goes well. So is there, do either of you have any common pitfalls that you've come across which lead to that unintended outcome and can potentially derail you in your attempts to digitalize the projects or the operations?
Yeah, I mean, there's some good examples out there where actually sometimes oil companies have kept their teams a little bit separate. So there's some FPSOs offshore Brazil where the data from the wells and the subsea leaves the FPSOs and goes to shore and goes to two different teams that are separated, and the teams don't work together except for at periodic intervals. So a subsurface reservoir team could be trying to optimize their subsurface, and they think that they've made the necessary changes, but without working together with the subsea team, they could find that they're getting some flow assurance issues, some slugging, hydrodynamic slugging, or gas fluctuations that could cause a problem in the subsea, or even in all the way up through the riser to the topsides for the control valves. So you have to, just because each individual team is using a lot of digital tools and dynamic simulations and everything, the things have to be linked, or you have the risk of missing something.
Great. Naser, anything from you?
So yeah, I think Dave mentioned the good point, but from my side, I should actually to somehow talk about the question. Basically, most of the time in subsurface, unfortunately, we don't see our mistakes to learn from that, and that's one of those things that again goes back maybe to your previous questions more, but we don't see our mistakes explicitly to see the process is not working very well and it can be done better. And that's one of the challenges that people have in subsurface digitalization, to show that we are making something maybe with the mistake and we can do it better. But this is very hard to show, at least in the subsurface, I would say.
Yeah, and one pitfall that we often see in the projects side is contractual alignment. I mean, I think if you want this extraordinary outcome and you want to move towards this unmanned, minimally manned, digitally enabled, then you have to align, put the right things in the right contracts to get that. And there's a couple of common pitfalls. If you want the digital model from your supplier of a piece of equipment, then you've got to put that in the contract. Otherwise, you're likely to get asked to build more money for it. If you're going down a lease operate model for an FPSO, then if the lease operator is being paid to have 70 people on board the FPSO, then there's no incentive for them to move to 50 or 30 or 20. And so I think there's an alignment around this whole contractual piece, having a common vision. So the team is there's no silos between the company teams, but also there's no silos between the major vendors that are going to contribute to this. So I think that's very, very important. We've had a couple of questions in. One question, has this process been tested on land-based wells? Yes, I think the answer to that is yes. We are seeing some quite remarkable things being done in Australia and in New Zealand, surprisingly. So there's a number of operations there in Queensland, coal bed methane to LNG assets, where all of the upstream assets are being remotely controlled from the centre of Brisbane. And in fact, they've been doing this since 2012, 2013, and they had a very big driver to move to that model because the cost of people in Australia was very high, and there was a shortage because there was a boom, simultaneous boom in oil and gas and mining at the time. So if you could swing a spanner, you could get a job. So consequently, they've been at the forefront of looking at minimum facilities, remote control, and very high visit frequencies. So there's a few good examples in Australia and New Zealand if you're interested. One other question, and this is from Joseph. Most often projects and assets require significant contractor involvement through the various phases of life cycle. Have you seen the integration across contractors with this model? So that's, yes, I talked a little bit about that. Dave, have you got any comment on contractor integration?
One of the nice things about the digital transformation is we're able to gather our IoT data from our remote facilities, and we can actually put it in cloud data platforms where multiple technical teams can access it. So you can have design engineering people, people are doing analysis, go up and access the data to check things. You can have technical specialists from your suppliers go and access and as part of their healthcare contracts. So the data is able to be shared across multiple technical teams, from whether they're inside the operator or the contractors, to get the best technical information fed back to our field teams. So it's very powerful.
Just to add to that, I think one of the other examples I have seen on that matter is the autonomous well that I talked in my slide about that. We see that now many sensors makers and the contractor that are installing sensors basically put the data and share the data on a common platform and cloud to be used for other purposes by maybe even other contractors or even other people. So that's also very exciting that now people can share their information, and they see that, for example, they are bringing one value, but maybe the device or the data that they are streaming brings other value to that company too. So that's also exciting too.
Yep, and that that also addresses one of the final questions we've got, which is how do you bring back the large amount of data from the field back to the office? I mean, for me, I think this is a problem that has been solved already. It's just a fact of whether you can afford to do it or not. I mean, if an operation is brand new and you have a pipeline, the cost of putting a fiber optic on the back of the pipeline is negligible, and in which case you have unlimited bandwidth. It's more difficult in extremely remote areas, but even then we are seeing. I was in an operational site in Kazakhstan in 2009, and it had fiber then. So there are certain areas and certain basins where this is still a challenge, but I think it's just a matter of time before somebody solves wide area Wi-Fi or the low orbit satellites, or the fiber just becomes ubiquitous everywhere.
5G.
5G, yeah, the comms problem I think is going to go away. And we're already seeing it go away in many areas. There's one company in Australia that actually put a 4G network over its whole of its basin of operations in the Cooper Basin, because they got to the point where they couldn't do more with digital unless they had the comms. So it's a fundamental enabler, and you've got to build it into the cost of working this way ultimately. But I think the cost of this is reducing rapidly, so I think it will be ubiquitous to everybody. So just a little bit, 1 minute to wrap up. Thank you very much, Naser. Thank you very much, Dave. Thank you very much to Upstream Intelligence and Reuters Events and Jade for organising this. It's been a pleasure to be on this webinar, and hopefully we'll get a chance to do this again. If you've got any feedback, I'm sure that can go through to Upstream Intelligence, and we can improve on it for next time. But thank you very much for listening. Thank you, gents.
Yeah, thanks so much, Tony. Unfortunately, that is all we have time for. There are some questions still coming through. There's things on drilling, process automation, and data analytics. all of which will be answered at the 6th Data-Driven Drilling and Production Conference on June 16th and 17th in Houston. So if you do have any unanswered questions, please do join us there this June. With over 180 of the biggest names already signed up, it's looking to be a great event. To learn more, you simply go to www.upstreamintel.com/data. Many thanks again to Tony, Dave, and Naser for participating today. I'm sure you've all found their insight valuable. You'll have access to the full audio replay and presentations, so please share them with your colleagues, clients, and the whole community. We want to spread the knowledge as much as possible. Thanks so much for tuning in, everyone. Bye.